The world of AI is moving at warp speed, isn't it?
It really is. Feels like something new drops every week.
It's almost dizzying. Keeping up is practically a full-time job. But that's why we're here. Welcome to the AI Checkpoint. Today we're doing a deep dive into something, well, pretty significant that just landed from OpenAI.
Yeah, their new open weight models, GPT-OSS 120B and the smaller 20B.
Exactly. So our mission today is pretty straightforward. We want to unpack these models for you. What makes them genuinely special? How do they actually perform out there in the real world? And maybe most importantly, why should you care? Whether you're building with AI or just trying to understand where this whole thing is headed,
Right.
you'll walk away with hopefully a really clear picture of what they can do, some interesting safety stuff they've built in, and how they might open up new doors. We're pulling this straight from OpenAI's announcement and the Hugging Face model cards.
And what's really fascinating, I think, is that these aren't just, slight improvements. They seem to be genuinely pushing the edge for open weight reasoning, bringing capabilities that until now were kind of locked behind closed doors, proprietary systems, and making them accessible for all sorts of different applications. It feels like a real shift.
Okay, so let's cut straight to it then. OpenAI, we all know them, ChatGPT, Sora, the big names. They've just released these two models, GPT-120B and GPT-120B. But the key phrase here, the kicker, is open weight. What does that actually mean in practice?
Yeah, that open weight part is absolutely crucial. Think of it like this. If you're a developer, you're not just getting an API call. You're getting the actual model weights, the engine
The
itself.
whole thing.
The whole thing. And that gives you just incredible flexibility. You can tinker, you can customize it, fine-tune it on your own data, deploy it commercially. And crucially, they come with an Apache 2.0 license.
Which is important because
Well, it's super permissive. It means you can build on top of it, even build commercial products without worrying about those restrictive copyleft licenses that sometimes force you to open source your own code or getting tangled up in patent stuff. It just frees up developers to innovate. It's a big deal.
that sounds like music to a developer's ears.
Yeah.
So what's the big promise from OpenAI? What are they saying this means for, the average builder or just someone curious?
Their main pitch is pretty clear. Strong real-world performance, but at a low cost. That's the goal. They've really optimized these things for efficient deployment. Even on hardware that's, closer to consumer grade.
Okay.
It's about making really advanced AI much more accessible than it's been.
So let's take the bigger one, the GPT-OSS 120B model. What can it actually do compared to, say, models we already know?
Yeah.
And what kind of hardware are we really talking about?
Right, so the 120B model specifically is getting performance pretty close to OpenAI's own A4 Mini,
Wow.
which is a very capable model they offer. And it hits these core reasoning benchmarks. But get this, it can run efficiently on a single 80 gigabit GPU.
80 gigs. Still hefty, but not like a whole data center.
Exactly. It's within reach for a lot more research labs, smaller companies, even individuals. And then the smaller one, the GPT-OSS 20B, that's even more accessible. It performs similarly to their O3 mini model, but it can run on devices with just 16 gigabytes of memory.
16 gigs. So like a decent laptop, maybe even edge devices.
Precisely. Think on-device AI, local inference where you want to keep data private, or just being able to rapidly test ideas without spinning up expensive cloud servers. That 20B model is perfect for that.
That is genuinely impressive, putting that kind of power within reach. How did they manage that level of performance with that efficiency? What's under the hood?
Yeah, this is where the tech gets really interesting. So they're transformer models, fundamental, but they use this technique called mixture of experts, or MOU.
Mixture of experts.
So for the big 120B model, even though it has a massive 117 billion parameters total, it only actually activates about 5.1 billion for any given token it processes.
Right.
And the smaller 20B model activates 3.6 billion out of its 21 billion total.
So why do that? Why MOE? What's the advantage of only lighting up a fraction of the brain, so to speak?
Efficiency, mostly. It drastically cuts down the amount of computation needed for inference, for actually running the model. Think of it like having lots of specialized experts inside the model, and it only calls on the relevant ones for the specific task or piece of text it's looking at.
Okay, makes sense.
So you get the benefit of that huge knowledge base, but without the massive computational costs every single time. They also use some other clever tricks, like specific attention patterns, they call them, alternating dense and locally banded sparse attention, similar to GPT-3.
Okay, technical term, but the upshot is efficiency again.
Yeah, basically smarter ways for the model to focus its attention, plus something called grouped multi-query attention, which helps with memory usage. And all this means they can handle really long inputs, up to 128,000 tokens natively.
128K context window. That's huge. You could feed it entire books.
Pretty much. Documents, code bases, long conversations. It can handle a lot of context.
So smart architecture, not just throwing more parameters at the problem. What about the training data? What do they feed these things?
They say it was trained mainly on a huge data set that was mostly English text, but with a specific focus on STEM subjects, coding, and general knowledge.
Okay.
But the training didn't stop there. After that initial pre-training phase, they put it through a pretty sophisticated post-training process that included supervised fine-tuning and then a high-compute reinforcement learning stage. This was all about aligning the models with what OpenAI calls their model spec.
And this post-training, why is that so crucial? What does it add?
It's absolutely key. This is where they teach the model how to think, essentially. They teach it to use chain of thought reasoning, breaking down problems step by step internally.
Right. Good.
And also how to use external tools, like figuring out when it needs to do a web search or run some code before it gives you the final answer. So it's not just pattern matching, it's learning a process for tackling complex requests. That's how they get those really strong reasoning abilities, similar to their O-series models.
That's fascinating. So they're not just text predictors. They sound much more active. You mentioned tool use. Can you expand on that? What does an agentic workflow look like?
You're spot on. They're designed for these agentic workflows. Agentic basically means the model isn't just passively answering questions. It can take action.
Yes.
Like imagine telling an AI to plan a trip. An older model might give you suggestions. An agentic model could potentially research flights, check hotel availability using web tools, maybe even draft booking confirmations by running code snippets.
Okay, wow.
It follows complex instructions, uses tools like search or code execution, reasons through multi-step tasks. It becomes more like an intelligent assistant that can do things, not just talk about them.
That feels like a significant leap. And you mentioned controlling its reasoning. How does that work?
Yeah, that's a really neat feature. Developers can actually adjust the model's reasoning effort. Just by putting a single sentence in the system prompt, you can tell it to use low, medium, or high reasoning effort.
So you can trade speed for depth.
Exactly. If you need a quick, simple answer, set it to low for lower latency. If you're tackling a really complex problem, crank it up to high for potentially better performance, even if it takes a bit longer. It gives you control.
Very cool. So, okay, putting it all together, the MOE, the training, the agentic stuff, how do they actually perform? What do the benchmarks say compared to other models people might know?
The results are genuinely impressive, especially for open models. On things like competitive programming, like code forces, general problem solving, like MMLU, tool use benchmarks, like TauBench, the GPT-OSS 120B is matching or even beating OpenAI's own A4 Mini.
Beating A4 Mini.
On some specific tasks, yeah. And here's a real kicker. On certain specialized benchmarks, like health-related queries, there's one called HealthBench, and on competition math problems from AME, the 120B model actually outperforms models like OpenAI o1 and even the very recent GPT-4o.
Outperforms GPT-4o on math and health. That's significant.
It is. It really shows their strength in complex reasoning domains. And even the smaller 20B model holds its own, matching or beating O3 Mini on those same tests. It shows these aren't just theoretical models, they have serious real-world utility.
And are people using them yet? Is it just benchmarks or are they out in the wild?
Oh yeah, OpenAI worked with early partners. Companies like AI Sweden, Orange Snowflake, they're seeing them used for all sorts of things already. Hosting them on-premise for data security is a big one. Fine-tuning them on specialized medical or financial data, it's happening now.
Okay. With all this power, though, especially being open-weight, safety becomes a huge question. How is OpenAI tackling that?
You hit on a critical point there, and they seem to be taking it very seriously. Safety was apparently foundational to this whole project. They ran these models through extensive safety training and evaluations.
Like what specifically?
Well, during pre-training, for instance, they actively filtered out harmful data related to things like CBRN chemical, biological, radiological, nuclear threats.
Oh, God.
And then in the post-training alignment phase, they used techniques like deliberative alignment and a safety hierarchy. Basically, teaching the model internal rules and processes to recognize and refuse unsafe requests or attempts to trick it, like prompt injections.
So building safety guardrails right into a thinking process.
Kind of, yeah. Teaching it how to evaluate requests for safety, not just giving it a list of forbidden words.
And you mentioned chain of thought access earlier. Is that related to safety?
It is, but it's a bit nuanced. You do get full access to the model's internal chain of thought, which is amazing for debugging.
Hmm.
You can see how it reached an answer.
It sounds useful.
It is, but OpenAI is very clear. Developers should not show that raw code directly to end users.
Why not?
Because that internal monologue, it can sometimes contain hallucinations or maybe harmful content the model considered but decided not to use, or even information it was explicitly told to exclude from the final response. It's a debugging tool, not user-facing content.
Okay, that makes sense. Keep the internal thoughts internal. What about the big fear with open models, someone taking it and fine-tuning it for bad stuff, malicious use?
Yeah, that's always the elephant in the room with open source AI, isn't it? And this is where OpenAI seems to have done some pretty novel work. They actually tried to do this themselves in a controlled way. They intentionally fine-tuned these models on specialized, potentially dangerous biology and cybersecurity data sets to see what would happen.
They try to make them malicious?
Essentially, yes, to test the guardrails. And crucially, what they found was that even these intentionally maliciously fine-tuned versions still couldn't reach really high, dangerous capability levels according to their own internal safety framework, the preparedness framework.
That's reassuring.
It is, and they had independent experts review this methodology. It feels like a significant step forward in how we evaluate the safety risks of open models before releasing them. They're trying to break it themselves first.
The proactive testing is good to hear, and they're bringing the community into it too.
Absolutely. They're launching a big red teaming challenge, $500,000 in prize money.
What?
Yeah, encouraging researchers and developers all over the world to poke and prod these models, find novel safety issues, find ways they might be misused. And they plan to publish a report on the findings and even open source an evaluation data set based on what the community discovers. It's about collective effort in making these things safer.
That's a great approach. Okay, so for people listening who are now thinking, right, I want to try these out.
Yeah.
How easy is it to actually get your hands on them?
They've made a really big push for accessibility here. Both models, the 120B and the 20B, are right there on Hugging Face. That's probably the easiest starting point for many.
The main hub for open models.
Exactly. But beyond that, they've partnered with tons of platforms, Azure obviously, but also other deployment services like VLLM, Llama, AWS. On the hardware side, they worked with NVIDIA, AMD, Cerebra's Grok to make sure performance is optimized.
So lots of options depending on your setup.
Yeah, and Microsoft is even bringing optimized versions of the GPT-OSS 20B model to Windows devices directly, so you can run it locally through tools like Foundry Local or the AI Toolkit for VS Code.
Yeah.
They really want these to be widely usable.
Which brings us back to the big picture, I guess. Why does this matter so much? Why are open models like these such a big deal?
It really gets to the heart of how AI develops, doesn't it? OpenAI's perspective seems to be that a healthy, vibrant, open model ecosystem is actually essential for making AI truly beneficial for everyone, everywhere.
So it's not just about competing with closed models.
No, they see it as complementary, giving developers a wider range of tools. Open models accelerate research across the board, they spark innovation in ways closed models might not, and they allow for more transparent, auditable AI development. That builds trust.
And accessibility.
Hugely important. Think about emerging markets, or nonprofits, or smaller companies maybe in education or healthcare. They might not have the budget or the flexibility to rely solely on proprietary APIs. Open models lower those barriers significantly. It's about democratizing access to this powerful technology.
So it's really about putting these powerful, accessible tools into more hands, letting more people around the world build, innovate, and figure out what AI can do.
Exactly. That's the vision. It's about fostering a broader community effort to push the boundaries.
Well, we've certainly covered a lot today, from the nuts and bolts of the GPT-OSS models, the MOE architecture.
Right. The performance benchmarks, which were pretty surprising in some areas.
Definitely. And OpenAI's approach to safety, which seems quite thorough, plus the massive push for accessibility. These models really do feel like a significant marker in the open-weight AI landscape.
Absolutely. And I think ultimately what really stands out is how these models democratize things. They invite so many more people into the fold to experiment, to build, to collaborate, and really to help define where AI goes next, but in a much more open and transparent way.
It opens up so many possibilities.
And just think what kinds of really specific, localized, maybe privacy-focused AI tools become possible when this level of intelligence can just run on your own machine completely under your control. It's kind of mind-boggling to consider.
It really is. Lots to think about. Okay, that's our deep dive for today. Hit like and subscribe if you like the content. See you next time.